Antarctica just revealed something horrifying beneath its ancient ice. A place once believed to be a frozen wasteland of silence and solitude has suddenly roared to life with a discovery so profound, it's forcing scientists to rethink everything we thought we knew about prehistoric life. Buried deep under layers of compacted snow and glacial ice, fossilized remains of a massive creature have emerged. But this isn't a dinosaur. This is something else, something even more terrifying. A true apex predator that once ruled the seas of an ancient world lost to time. The icy continent, long considered a final frontier for fossil hunters, has been guarding its secrets for millions of years. But now, as climate change accelerates the melting of Antarctica's permafrost and ice sheets, it's beginning to uncover a story frozen in time. And at the center of that story is a beast scientists didn't expect. Measuring possibly over 40 feet in length, with jaws built for crushing bone and speed that rivaled modern-day sharks, this predator didn't just survive in Antarctica's ancient waters, it dominated them. The find is already being called one of the most important fossil discoveries of the century. Not just because of its size, or the state of preservation, but because of what it tells us about the hidden ecosystems that once flourished beneath what is now a kingdom of ice. And while the world has known about fossils in Antarctica before, none have matched the scale and ferocity of this one. This isn't just a missing puzzle piece in prehistoric history. It's an entirely new chapter, one that rewrites how we view evolution, extinction, and the sheer diversity of life that once thrived in Earth's southernmost region. Paleontologists and marine biologists are stunned. Early reports suggest the creature may not fit cleanly into any known classification. Some speculate it's a new genus altogether, a long-lost cousin of the great marine reptiles like mosasaurs or plesiosaurs, but fiercer, more adapted, and more advanced than anything previously recorded. This isn't fiction. This isn't speculation. This is real. And what lies beneath the Antarctic ice might just be the most terrifying prehistoric predator ever discovered. Antarctica, the final paleontological frontier, where the ice guards Earth's deepest secret. While deserts, jungles, and mountain ranges across the globe have given up the bones of ancient beasts, Antarctica remains Earth's most mysterious graveyard. For centuries, this vast frozen continent has been cloaked in silence. A land where temperatures plunge below -80 degrees Fahrenheit, where winds can howl at hurricane force, and where darkness can last for months on end. It's no wonder that, until very recently, most scientists saw Antarctica as a dead zone, too hostile, too remote, and too frozen to hold any significant fossil record. But now, all that is changing. Antarctica is largely unexplored not because we lack the curiosity, but because we lack the access. The sheer thickness of its ice, sometimes reaching over 3 miles deep, has acted like a natural vault, locking away the secrets of Earth's deep past. Beneath this white expanse lies a lost world, untouched for tens of millions of years. The freezing climate preserved it like a time capsule, compressing layers of snow into dense ice that sealed ancient sediments far from view. Only with modern technology, satellite imaging, and ice-penetrating radar have scientists begun to peel back those layers. And what they're finding beneath is nothing short of astonishing. Long before Antarctica became the coldest place on Earth, it was something very different. Paleoclimatology studies and sediment core samples suggest that around 100 million years ago, Antarctica was lush and green. Dense forests lined its coastlines, rivers carved through fertile valleys, and warm, shallow seas teemed with life. It wasn't just habitable, it was thriving. Fossilized plant matter, including ferns and even palm trees, have been discovered embedded in rock formations near the Transantarctic mountains. These finds alone hinted at a dramatically different ancient climate. But it was the rare fossils of marine life and land-dwelling reptiles that truly caught the attention of the scientific world. Over the past few decades, small teams of paleontologists braving the harsh elements have recovered fossilized remains of marine reptiles like plesiosaurs and mosasaurs, as well as early birds and even fragments of ancient amphibians. These discoveries, though sparse, painted a picture of a once complex ecosystem, one where apex predators hunted, giant fish thrived, and flying reptiles soared across tropical skies. But the finds were always fragmentary, partial skeletons or isolated bones, difficult to study and even harder to confirm without full specimens. The harsh Antarctic conditions limited how much could be uncovered, and most expeditions returned with more questions than answers. Still, the pattern was clear. Antarctica was not just some icy desert at the edge of the world. It was a cradle of biodiversity. A place where evolution sculpted creatures unlike any found elsewhere. A place where life, both monstrous and majestic, once reigned supreme. And if the fossil record hinted at such diversity based on tiny fragments, the implication was staggering. Far more must remain hidden beneath the ice. Antarctica wasn't a blank slate, it was a paleontological frontier just beginning to reveal its depth. The extreme climate has been both curse and blessing. It made exploration nearly impossible, but it also preserved what it buried. Fossils that would have eroded or decayed in more temperate regions remained intact beneath the ice. This natural preservation is why scientists believe that what we've uncovered so far is only the beginning. As the ice sheets thin and glacial movement accelerates due to global warming, long-buried fossils are being pushed closer to the surface. What's emerging now is not just another discovery, it's a warning that the ancient world is waking up. And now, with the recent unearthing of a massive apex predator, larger, more complete, and more intact than anything found before, the belief that Antarctica holds the keys to prehistoric history is no longer a theory. It's a fact. This is no longer the land of the unknown. It is the final frontier for paleontology. Every layer of ice removed, every rock chipped away, brings us closer to understanding a lost world that once thrived beneath the southern sky. A world whose deadliest inhabitant has finally been found. The discovery, unearthing the beast, a hidden monster emerges from the ice. The world first learned of the discovery through a quiet academic announcement that quickly exploded into global headlines. Beneath one of the most isolated and windswept ice shelves on Earth, a team of international paleontologists working on a routine geological survey had stumbled upon something extraordinary. The site was near the base of the Transantarctic Mountains, an area historically known for yielding rare fossilized plant life. But no one expected to find the remains of what would become one of the most jaw-dropping prehistoric predators ever uncovered. The expedition was part of a long-term research program jointly managed by the British Antarctic Survey and a team from Argentina's Instituto Antarctico. Their original mission was to study shifting geological strata exposed by receding glacial ice. During the final days of the expedition season, as temperatures warmed and layers of sediment began to emerge, one researcher noticed a strange pattern in the rock. What looked like a jagged outcrop was, in fact, the curved remains of an enormous rib cage, fossilized in near-perfect condition. Further excavation revealed a partial but extensive skeleton embedded within the frozen rock. The bones had not been scattered or eroded as so many other Antarctic fossils had been. They had been locked in place by compacted sediment and ice for nearly 90 million years. From the first exposed fragments, a section of spine and jawbone, it was clear this was not an ordinary find. The jaws alone measured nearly 6 feet across, studded with dagger-like teeth that curved inward, designed to grip and shred flesh in a single bite. Based on the preserved vertebrae and limb structures, scientists estimated the full length of the creature at over 12 meters, or nearly 40 feet. This wasn't a dinosaur. This was something different. Something built for speed, dominance, and deep-sea ambush. A marine superpredator with power exceeding anything currently swimming in our oceans today. Early comparisons were drawn to mosasaurs, ancient marine reptiles that once terrorized Earth's oceans during the late Cretaceous. But even among that formidable family, this specimen stood out. Its bone structure was thicker, suggesting it could dive to extreme depths. Its flippers were larger than any known mosasaur fossils, possibly hinting at faster acceleration or more agile underwater movement. The tail vertebrae were elongated, suggesting it may have had a flexible, eel-like propulsion system, a design unseen in other marine reptiles of the time. The scientific world responded with a mix of awe and disbelief. Initial images from the excavation site were circulated through academic journals before reaching mainstream media, where they triggered a frenzy of speculation. What species was this? Could it be a previously unknown genus? If so, how many more of its kind might still be buried beneath the ice? Within weeks, the discovery was being dubbed the Antarctic Leviathan across headlines, social media, and scientific podcasts. But behind the media frenzy, serious research was already underway. Carbon dating, while not typically used on fossils of this age due to its limits, was complemented by advanced stratigraphic analysis and uranium-lead isotope testing. These methods provided a surprisingly tight estimate. The fossil was deposited between 75 and 90 million years ago, placing it squarely in the late Cretaceous period. At that time, Antarctica was positioned slightly closer to the equator, enjoying a much warmer climate and teeming with marine life. What shocked scientists further was the sheer completeness of the fossil. Nearly 70% of the skeleton had been preserved, including much of the skull and lower jaw, both forelimbs, several vertebrae, and large portions of the rib cage. Most marine fossils recovered from Antarctica were mere fragments, isolated bones or fossilized teeth. This one, however, offered a near-complete anatomical blueprint. With 3D imaging and CT scanning, researchers were able to reconstruct its muscular and skeletal system in digital form, creating one of the most accurate models ever made of an ancient sea predator. This degree of preservation also revealed unique features never before seen in other specimens. One of the most baffling discoveries was a secondary jaw joint, similar to that of modern-day snakes, allowing for extreme flexibility when swallowing large prey. Coupled with its narrow skull and serrated teeth, it's now believed this predator could consume animals nearly half its size in a single lunge. Biologists studying the fossil proposed that this creature didn't just hunt. It vacuumed prey out of its environment, using speed and suction to overwhelm fish, squid, and possibly even smaller reptiles. This discovery isn't just a triumph for paleontology. It's a message from the past, a frozen scream echoing through deep time. A creature perfectly engineered for dominance that hunted long before humans even existed. Its bones, preserved in Antarctic silence for eons, now tell a story no one expected to hear, a story still unfolding as more of its icy tomb is slowly revealed. What was this giant predator? A beast beyond classification. The skeleton unearthed from beneath Antarctica's ice was more than just a rare fossil. It was a riddle carved into stone, a challenge to everything paleontologists thought they understood about the creatures that once dominated Earth's oceans. As the excavation progressed and the bones were studied under increasingly sophisticated imaging systems, one question loomed larger than any other. What exactly was this predator? At first glance, it bore similarities to a mosasaur. The long body, the paddle-like limbs, and the menacing array of conical teeth all pointed to this notorious family of marine reptiles. Mosasaurs, after all, were apex predators during the late Cretaceous period. But as scientists reconstructed the skull and spine, they realized this creature didn't quite match anything found in the known mosasaur lineage. The jaws were more elongated, almost crocodilian, yet narrower and designed for extreme speed. Each tooth, sharp and backward curving, was built not just to pierce flesh but to prevent prey from escaping. A second row of smaller, backward-pointing teeth ran along the roof of the mouth, a detail more reminiscent of serpentine anatomy than a typical marine reptile. It was a predatory design that spoke of brutal efficiency, as if nature had fused the most lethal traits of snakes and sharks into a single organism. The jaw could open wider than most known mosasaurs, suggesting an even more terrifying feeding mechanism. Unlike traditional bite and tear predators, this creature could unhinge its lower jaw and use a combination of suction and pressure to engulf its prey whole. The flexibility in the jaw joint, paired with unusually strong ligaments, indicated it could absorb the violent thrashing of captured animals without dislocating its skull. Its throat and upper digestive tract, preserved in fossilized muscle imprints, appeared to be lined with protective ridges that would allow it to swallow prey nearly half its body size without injury. Its flippers were massive and deeply muscular, each joint allowing a wider range of motion than seen in mosasaurs or plesiosaurs. These limbs weren't just for swimming, they were for maneuvering with surgical precision. Combined with a long, muscular tail and an advanced set of vertebrae that hinted at rapid flexing and twisting, the creature likely had the speed and agility to ambush prey in the blink of an eye. Paleobiologists now believe this predator may have been capable of explosive bursts of motion, much like today's orcas or great white sharks, but on a scale far beyond anything alive today. So where does it fit in the scientific tree? That's the real dilemma. Some experts have argued it belongs to an as yet undiscovered branch of the mosasaur family tree. Others insist it's closer to plesiosaurs, whose barrel-shaped bodies and crushing jaws dominated earlier prehistoric seas. But the evidence doesn't quite fit either mold. Instead, it seems to represent something entirely new, a marine reptile that developed in isolation, possibly due to Antarctica's unique position during the Cretaceous period. With rising seas, shifting land masses, and warmer global temperatures, it's possible that this predator evolved in a distinct ecosystem, feeding on a prey base that favored speed, stealth, and raw power over sheer size alone. Its closest analogues today are more terrifying for what they suggest than what they prove. Modern-day apex predators like killer whales and great white sharks rely on intelligence, pack behavior, and highly adapted physiology to rule their ecosystems. But this Antarctic creature, without the benefit of mammalian intelligence, appears to have achieved that dominance through raw evolutionary design. Pound for pound, it may have been stronger, faster, and more lethal than any known predator of its time. And it did so alone, with no evidence yet of social behavior or group hunting tactics. The terrifying implications of its size and strength go beyond mere scale. If this creature hunted in Antarctica's warm prehistoric waters, it must have fed on some of the largest marine animals of its age. That means whales were not yet on the menu, but giant ammonites, armored fish, and even other marine reptiles likely were. With a body that large and jaws built for maximum carnage, it may have been the uncontested ruler of its domain. No rival, no threat, no competition. A superpredator in the truest sense of the word. And what does it mean for our understanding of prehistoric life in Antarctica? Quite a lot. It suggests that the continent wasn't just a tropical haven for plants and small marine creatures. It was a killing ground, where some of Earth's most fearsome predators thrived. The fact that such a creature remained undiscovered until now hints at just how incomplete our picture of ancient ecosystems really is. For decades, paleontologists believed the most extreme marine predators came from the northern hemisphere. The idea that the southern hemisphere, and Antarctica in particular, could host a rival, or perhaps even a superior predator, upends centuries of evolutionary assumptions. It also raises haunting questions about what else may lie beneath the ice. If one predator of this magnitude has been found, how many others remain hidden? Are there entire food chains, entire evolutionary branches, waiting to be revealed? This fossil could be just the beginning of a deeper paleontological awakening, one that challenges not just our understanding of the creatures that once ruled the oceans, but the very origins of predatory evolution. Whatever this predator truly was, one thing is certain. It wasn't just a marine reptile. It was a masterpiece of survival, sculpted by time, buried in ice, and now reborn through science. A monster from the deep, perfectly designed for a world long gone, and Antarctica's prehistoric past, a tropical ocean world. When the frozen continent teemed with life, today, Antarctica is a world of silence and ice, an unforgiving desert of snow where only the hardiest creatures survive. But rewind the clock back to the Cretaceous period, and the continent tells an entirely different story. Beneath its frozen surface lies a buried chapter of Earth's history, one where Antarctica was not a wasteland, but a thriving, lush, temperate environment, complete with forests, freshwater lakes, and warm, shallow oceans brimming with life. This stark contrast has stunned geologists and paleontologists alike, and the recent discovery of a massive marine superpredator only adds to the growing body of evidence that Antarctica was once a tropical ocean world. Geological surveys of the region have revealed rich sedimentary layers filled with clues about the ancient climate. Fossilized tree trunks, pollen grains, and plant matter embedded in sandstone have been found deep beneath the ice. These are not remnants of moss or cold-weather shrubs. They are the remains of towering conifers, ferns, and even flowering plants, flora that could not have survived in freezing conditions. These samples suggest that during the mid to late Cretaceous, Antarctica supported a climate more akin to modern-day New Zealand or southern Chile. Average summer temperatures may have hovered between 14 to 20 degrees Celsius, warm enough to support complex ecosystems above and below the surface. Climate models based on these findings reveal an ancient Antarctica vastly different from today's icy landscape. During the Cretaceous, the continent was situated slightly farther north and was part of a global greenhouse climate era. Atmospheric carbon dioxide levels were several times higher than they are now, leading to warmer poles and rising sea levels. Instead of being sealed off by ice, Antarctica's coastlines were dotted with lagoons, estuaries, and shallow seas. These waters were rich in nutrients, fed by volcanic activity and sediment runoff from inland rivers. The result was an environment capable of supporting large marine reptiles, fish, invertebrates, and complex food chains that rivaled those of any other part of the prehistoric world. The recent unearthing of a superpredator fossil offers powerful confirmation of these climate models. This creature could not have existed in a frozen ocean. Its physiology, designed for warm, fast-moving waters, points to a marine ecosystem where temperatures were mild and biodiversity was high. It needed an abundant supply of large prey to survive, suggesting the presence of numerous fish species, squid, and other marine reptiles. The sheer size of its jaw and the structure of its teeth indicate it likely fed on animals nearly half its size, and perhaps even scavenged from other large predators. That kind of apex role requires a dense food web, one only possible in a thriving, productive sea. Supporting this vision of Antarctica's tropical past are numerous fossil finds that have emerged over the last several decades. Along with the recently discovered predator, scientists have also uncovered fossils of plesiosaurs and ichthyosaurs, both large marine reptiles that dominated the seas during the Mesozoic era. In addition to these giants, smaller but equally important species have been found: bony fish, early forms of turtles, marine invertebrates, and even signs of microbial reefs. These discoveries, though limited by the harsh working conditions and logistical difficulties of Antarctic expeditions, suggest a biodiversity that is only beginning to be understood. In 1986, a research team found fossilized remains of an ammonite, a shelled marine mollusk, in Seymour Island, just off the coast of the Antarctic Peninsula. Not only was this species previously unknown, but its preservation was so intact that fine shell ridges could still be observed under magnification. In more recent years, researchers working in James Ross Island found the fossilized bones of an enormous elasmosaur, a long-necked marine reptile that once cruised through ancient waters. These fossils were not randomly scattered or weathered. They were embedded in sedimentary layers that spoke of calm seas, slow silt accumulation, and stable conditions, a far cry from the frozen chaos of the continent today. The ice itself has been an accidental ally in preserving this hidden record. For millions of years, glacial buildup has acted as a natural refrigerator, locking sediments and fossils beneath its crushing weight. But that same ice has also hidden these secrets from view. Now, as global temperatures rise and the ice begins to retreat, that prehistoric archive is slowly emerging into the light. With every melting glacier and collapsing ice shelf, the potential for new discoveries grows. And if one apex predator has been revealed, it's likely that more are waiting in the shadows, frozen in place, ready to challenge our understanding of Earth's ancient oceans. Perhaps the most exciting implication of all is that Antarctica may not have been a passive region during prehistory. Far from being a fringe ecosystem, it could have been a biological hotspot, an evolutionary laboratory that produced unique adaptations and new species unlike any found elsewhere. Its isolation, even during the Cretaceous, would have allowed life to develop along independent paths. That could explain why the giant predator recently discovered defies easy classification. It may not be a global cousin to known marine reptiles. It may be a local phenomenon, an Antarctic native shaped by a hidden world we're only now beginning to access. The idea of a tropical Antarctica filled with monstrous reptiles, thriving coral systems, and massive underwater hunters may sound like science fiction. But the data is real, and the fossils are undeniable. The continent we see today, barren, frozen, and lifeless, is merely a surface illusion. Beneath lies an ancient paradise turned graveyard, a world erased by time and climate, yet perfectly preserved in silence. As the ice melts and science digs deeper, we're not just uncovering bones. We're awakening a prehistoric world that has been waiting, patient and still, under Antarctica's eternal winter. Global climate shifts and fossil preservation. And when ice becomes the guardian of the past, in the ever-changing story of Earth's deep history, few places have preserved the ancient past as faithfully as Antarctica. While glaciers often symbolize destruction, erosion, and relentless force, in the case of fossil preservation, they have acted as guardians. The freezing climate that now defines Antarctica has become the very reason these fossils remain so intact. Sealed beneath millions of tons of glacial ice, ancient bones, sediments, and even plant material have been frozen in time, shielded from wind, water, and erosion. It is a paradox of nature. One of the harshest climates on Earth has become one of the best preservers of prehistoric life. As Antarctica transitioned from a warm, life-filled continent into a frigid desert, the snow and ice that began to blanket its surface slowly built up over time. With each new layer of snowfall compacted into solid ice, ancient sediments were pressed deeper into the ground. The temperature dropped, water content froze solid, and microbial activity ground to a halt. Unlike other parts of the world where organic material is broken down by weather, bacteria, and shifting tectonic plates, the Antarctic cold slowed those processes to a near standstill. The fossilized bones of marine reptiles, like the recently discovered superpredator, remained untouched for tens of millions of years, protected from decay by the same ice that now makes their retrieval so difficult. But Antarctica's ice is not entirely still. Glaciers are in constant, albeit slow, motion. Over thousands of years, glacial flow has gradually pushed ancient sediments toward the surface. These movements act like natural conveyor belts, slowly bringing fossils embedded deep in rock closer to the outer layers where they might be revealed by seasonal melt or exposed by geological fractures. As glaciers carve their way across the continent, they grind down some fossils while elevating others into accessible zones. This dynamic process is how some of the continent's most important fossil discoveries, including the massive sea predator, have emerged from obscurity. It is only recently, however, that the pace of exposure has begun to accelerate. Climate change has added a new and urgent dimension to paleontological research in Antarctica. As global temperatures rise, the continent is experiencing unprecedented levels of ice melt. Some of the fastest warming on Earth has been recorded along the Antarctic Peninsula, where average temperatures have increased by nearly 3 degrees Celsius over the past half-century. Glaciers that remained stable for millennia are now retreating at record rates, revealing ancient terrain that has not seen daylight since the age of the dinosaurs. This accelerated melting, while alarming for climate scientists, has created an unexpected window of opportunity for paleontologists. Fossils that would have remained locked away for another 100,000 years are now appearing within a single generation. In some areas, researchers have reported finding fossilized remains mere inches below the surface, unearthed by nothing more than seasonal thaw. As the ice recedes, so too does the barrier that kept these fossils buried. The result is a surge in discoveries, many of which challenge existing theories about prehistoric ecosystems and evolutionary timelines. What makes this phenomenon even more remarkable is the quality of the fossils being found. Bones preserved under Antarctic ice often retain incredible detail, from the ridges of muscle attachments to the serration of teeth. In rare cases, fossilized soft tissues and skin impressions have also been found, offering an unparalleled glimpse into the anatomy of long-extinct creatures. It is this pristine preservation that allowed scientists to reconstruct the Antarctic superpredator with such clarity, revealing anatomical features never before seen in related species. Yet there is a looming sense of urgency that accompanies these discoveries. As ice melts and glaciers collapse, newly exposed fossils become vulnerable to the elements. What remained protected for millions of years can be destroyed within days by wind, rain, or temperature fluctuations. This has prompted international teams to increase the pace of exploration and preservation. Drone surveys, satellite imaging, and automated sampling are now being deployed in areas considered high risk for rapid ice loss. These tools allow scientists to identify potential fossil sites before erosion can wipe them clean. In many ways, Antarctica is becoming a race against time. Every melting glacier brings new revelations, but also new threats. The preservation window that ice once guaranteed is now closing as quickly as it opens. The fossil of the giant sea predator is both a triumph and a warning. It reminds us of what is possible when nature preserves its history, and what we risk losing if we fail to act quickly. Antarctica has kept its secrets for millions of years, but now, as the climate shifts and the ice retreats, those secrets are emerging at a pace never seen before. The question is no longer whether Antarctica holds more ancient creatures. It's how many will we find before they vanish again, this time, not beneath the ice, but into the dust of erosion and time. Rewriting the rules of prehistoric predators. When news of the Antarctic predator fossil broke across scientific communities, the immediate response was awe. But awe quickly turned into disruption. The discovery didn't just add another creature to the fossil record, it shattered long-standing assumptions about the evolution of apex predators and the ecological hierarchy of the ancient oceans. What began as a single excavation has snowballed into one of the most controversial and compelling chapters in modern paleontology. For decades, the evolutionary path of marine predators was considered relatively stable. The general consensus held that during the late Cretaceous period, powerful apex predators like mosasaurs and plesiosaurs dominated northern hemisphere oceans. Fossil records from North America, Europe, and parts of Asia supported that view. But the sudden emergence of a massive, hyper-adapted predator from Antarctica, one potentially unrelated to the known marine reptile families, throws a wrench into that narrative. The fossil's anatomical features are not just unique. They are advanced. Its flexible jaw structure, high muscle attachment points, and hybrid swimming mechanics suggest an evolutionary leap that doesn't match the slower, more linear development of known mosasaurs or plesiosaurs. It's as if evolution hit the fast-forward button in this corner of the world, producing a predator that was not only built for killing but built smarter, stronger, and perhaps earlier than its rivals elsewhere. This has led to heated debate in paleontological circles. Some scientists argue that the predator is a variant of an already known genus, possibly an isolated form of mosasaur that developed differently due to the unique Antarctic environment. But others believe that it is something altogether new, a species that evolved independently and perhaps branched off from an unknown ancestral line. If confirmed, this would represent not just a new species but potentially a new genus or even a new family of marine reptiles, an entirely separate evolutionary experiment in apex design. The classification challenges are more than academic. They force scientists to re-evaluate the speed and distribution of marine predator evolution. If such a creature existed in Antarctica during the late Cretaceous, what does that say about global oceanic ecosystems? Was the southern hemisphere more biologically advanced than previously believed? Did isolation promote accelerated evolution in marine reptiles? Or were scientists simply looking in the wrong places all along? Further complicating the picture is the predator's inferred role in its ecosystem. Based on the size of its jaws and the estimated muscle power reconstructed from the fossil, it likely fed on very large prey. That suggests a complex, layered food web capable of sustaining multiple tiers of marine life. Smaller reptiles, large fish, cephalopods, and potentially even other predators may have made up its diet. This in turn implies that the southern hemisphere was not just home to this one monster, but possibly to a variety of advanced marine life forms, most of which remain undiscovered beneath the ice. The idea that the Antarctic seas could rival or even surpass the biodiversity of their northern counterparts is deeply unsettling to traditional models of prehistoric biology. For centuries, scientific exploration and fossil hunting have focused on temperate and tropical regions. Antarctica, due to its inaccessibility, was viewed as an afterthought, a region unlikely to yield anything but the occasional fragment. Now, that belief is collapsing under the weight of irrefutable evidence. In the wake of this discovery, researchers have begun questioning whether this predator was part of a larger, global class of apex marine reptiles. Could similar predators have existed elsewhere and simply haven't been found yet? Were these creatures connected by ancient ocean currents that allowed genetic drift between hemispheres, or were they isolated phenomena that developed in response to specific environmental pressures? The implications reach beyond paleontology and into geology, climatology, and evolutionary biology. Some believe that this Antarctic beast may be the first member of a previously unknown class of hyperpredators that emerged late in the Cretaceous period. Others suggest that its existence could explain gaps in the fossil record, gaps that were previously dismissed as missing data but now may represent blind spots in global sampling. This fossil has reignited calls for more funding, more Antarctic expeditions, and more open-minded approaches to classifying marine reptiles whose features do not fit neatly into existing boxes. There's also a philosophical shift underway. The discovery challenges the idea that science has already uncovered the major branches of prehistoric life. It reminds researchers that Earth's evolutionary story is still full of blank pages. The frozen wastelands of Antarctica, once written off as inhospitable and irrelevant to major prehistoric developments, are now being viewed as key chapters in the global story of life on Earth. For the general public, the story is captivating. For scientists, it's a call to arms. The timeline of predator evolution has just been rewritten, and the ink is still drying. What was once a stable narrative of linear progression, from early fish to advanced reptiles to dominant mammals, is now splintered by the revelation of a beast that doesn't fit the mold. In a field where classification, chronology, and clarity are everything, This one fossil has created chaos. And yet, in that chaos lies the potential for deeper truth. A truth buried in ice, defying expectations, and demanding to be explored. Prehistoric superpredators, global comparison, and the leviathans that ruled Earth's ancient oceans. To understand just how extraordinary the Antarctic predator truly is, it helps to place it beside the other apex predators that once ruled Earth's oceans and landscapes. For generations, creatures like Megalodon, Spinosaurus, and Kronosaurus have stood at the top of the prehistoric food chain in our imagination. Each of them, in their own era and ecosystem, represented nature's most terrifying blueprint for dominance. But now, with the discovery of a giant sea predator preserved beneath Antarctica's ice, the global rankings of these ancient monsters may need to be re-examined. The Megalodon has long enjoyed a fearsome reputation. Roaming the oceans approximately 23 to 3 million years ago, this colossal shark measured up to 60 feet in length and wielded the most powerful bite force of any known marine animal. With jaws that could crush a car and teeth the size of human hands, Megalodon was the uncontested ruler of the post-dinosaur oceans. But despite its size and savagery, Megalodon lived long after the reign of marine reptiles had ended. It thrived in a different era, when whales had already become its primary prey. While it was the largest shark to have ever existed, its evolutionary path was completely separate from the reptiles that came before it. Earlier still was Kronosaurus, one of the most formidable plesiosaurs of the early Cretaceous period. Measuring around 33 feet in length, it had a compact, muscular body, short neck, and a massive head filled with conical teeth designed to seize and crush prey. Kronosaurus was built for raw power and ambush hunting, using its flippers to lunge forward at incredible speeds. Its territory included the warm, shallow seas of what is now Australia and South America. For decades, Kronosaurus was considered the pinnacle of marine reptile predation. Yet in size and structural complexity, it may have just been dethroned. Then there is Spinosaurus, a creature that straddles the line between land and water. At over 50 feet long, it was the largest known carnivorous dinosaur, even surpassing the legendary Tyrannosaurus rex. With a long, crocodile-like snout and dense bones adapted for buoyancy, Spinosaurus is believed to have spent much of its life in aquatic environments. It likely hunted fish and smaller marine reptiles in river systems and coastal lagoons. Its semi-aquatic lifestyle makes it a fascinating but imperfect comparison to fully marine predators. Still, its size and versatility earn it a place in the elite class of prehistoric apex hunters. What makes the Antarctic predator so unique in this lineup is not only its size, which is estimated at nearly 40 feet, but its design. Where Kronosaurus favored brute strength, and Spinosaurus relied on hybrid agility, this new predator appears to blend both strategies with added refinements. Its elongated, flexible jaw, advanced muscle structure, and serpentine propulsion suggest a creature capable of high-speed attacks and precision strikes. It wasn't just big. It was smartly built, honed for mastery of its domain. In many ways, it may have represented the final evolutionary word in reptilian ocean dominance before the mass extinction at the end of the Cretaceous period. Size alone cannot tell the full story. Ferocity, agility, and territory are equally important when considering an apex predator's power. Based on the fossil's muscle attachment points and jaw reconstruction, this Antarctic beast may have had one of the strongest bite-to-body ratios of any marine reptile. Its ability to hunt in both open waters and coastal zones gave it a wide reach. And the suggestion that it could consume prey nearly half its own size puts it in a category shared by very few predators, living or extinct. If Megalodon was the brute force predator of its age, this Antarctic hunter was the surgical killer of its time. The possibility of interaction or competition between prehistoric superpredators is a tantalizing one. Did their paths ever cross? Could these monsters have hunted the same waters or preyed upon one another? In most cases, the answer lies in geological timing. Megalodon lived millions of years after the extinction of marine reptiles like Kronosaurus and this Antarctic species. Spinosaurus, while impressive, lived on a different continent and primarily hunted in rivers and estuaries. Kronosaurus, however, lived during the early Cretaceous, potentially placing it closer in time to the Antarctic predator. But with an ocean and tens of millions of years between them, direct competition remains unlikely. Still, ocean currents during the Cretaceous period connected vast regions of the globe. Marine reptiles may have traveled farther than we can imagine, their migration patterns dictated by climate, prey availability, and breeding cycles. It's not impossible that large predators overlapped in territory during certain periods, especially in regions where nutrient-rich waters supported dense populations of prey. While no fossil evidence has yet placed these predators in direct conflict, the theoretical overlap fuels scientific curiosity and public imagination alike. What the Antarctic discovery truly challenges is our sense of dominance and hierarchy among prehistoric predators. This fossil doesn't just rival known marine reptiles in size and lethality. It introduces a new contender into a class of monsters we thought was already full. The idea that such a creature remained hidden for so long beneath the ice is both humbling and thrilling. It's a reminder that our understanding of Earth's ancient ecosystems is still in its infancy. As scientists continue to study the fossil and compare it to known species, the larger question emerges. How many more superpredators remain to be found? Were there localized apex hunters in other isolated regions of the planet? Could Antarctica be the missing link in a global predator map that spanned millions of years and uncountable miles of ocean? The answers may lie frozen under layers of ice, waiting to rise from the depths just like this one did. In the grand pantheon of prehistoric predators, the Antarctic leviathan has now taken its place. Whether it was the fiercest of them all or simply the most mysterious, its emergence from the ice has changed the conversation. It stands shoulder to shoulder with Megalodon, Spinosaurus, and Kronosaurus, each a reminder of nature's most fearsome designs, each a masterpiece of evolutionary power. Theories and controversies. When science meets mystery beneath the ice. As with any major paleontological discovery, the fossil of the Antarctic superpredator has stirred more than just scientific excitement. Alongside legitimate academic inquiry has come a flood of theories, some grounded in evolutionary biology, others floating in the outer edges of speculation. This fossil, so well preserved and so unique in structure, has ignited debates not only within the scientific community but also across the wider public consciousness. Was this creature a product of isolated evolution, or could there be something more unsettling beneath Antarctica's ice? One of the most persistent fringe theories proposes that this predator may have evolved in complete isolation from the rest of the prehistoric world. Antarctica, due to its position on the globe and its geological drift, was increasingly separated from other continents during the late Cretaceous. Some theorists argue that this geographic seclusion allowed evolution to run unchecked, producing creatures far removed from the evolutionary paths taken elsewhere. Without predators to compete with or ecosystems to limit size and aggression, perhaps this predator became a regional anomaly, larger, faster, and more lethal than anything that shared the seas. However, isolation isn't the only theory capturing imaginations. A more controversial line of thought leans into the idea of engineered evolution. While not supported by mainstream science, some suggest that the precision and specialization of this creature's features are almost too perfect. The jaw structure, the propulsion system, the anatomical streamlining, all appear so well adapted that it has led a few to question whether such a predator could have evolved naturally at all. Could it have been a product of accelerated evolution driven by an unknown force? Could environmental radiation, underwater volcanic activity, or even intelligent intervention have shaped such an efficient hunter? The mystery has only deepened with comparisons to modern legends surrounding Antarctica. One of the most well-known is the tale of the Ningen, a supposed cryptid described by Japanese whale fishermen as a massive, white, humanoid creature spotted in Antarctic waters. Descriptions often portray the Ningen as a ghostly being with arms, a face, and a size rivaling that of whales. While there is no scientific evidence to support these claims, the eerie resemblance to a massive creature hidden beneath the ice has drawn renewed attention in light of this fossil discovery. Some believe that stories like the Ningen may have been distorted memories or misidentified sightings of creatures similar to the one now recovered by scientists. Others take this speculation further, suggesting that Antarctica's ice has preserved more than just fossils. They point to strange sonar readings, unexplained radar anomalies, and deep subglacial lakes that remain completely unstudied. These theories are often dismissed by academics, but the truth remains that only a fraction of the continent has been thoroughly explored. The fossil discovery itself is proof that monumental finds can still be made under relatively thin ice sheets. That possibility leaves the door open, not just for further paleontological discoveries, but for the re-examination of legends that were once brushed off as folklore. In response, the scientific community has been measured but firm. The fossil has undergone rigorous analysis, with peer-reviewed studies pointing to its natural origins and its alignment with known evolutionary principles. Comparative anatomy supports the idea that this was an advanced marine reptile that evolved features to suit its environment. Core scans, isotopic testing, and sediment analysis all support a timeline consistent with natural history. There is no evidence of tampering, no anomalies in fossil composition, and no indication of artificial interference. But even among scientists, there is a quiet acknowledgement that this fossil challenges their assumptions. While it may not prove fringe theories correct, it does highlight how little is truly known about Antarctica's ancient ecosystems. Beyond the classification debates and the cryptid comparisons lies a growing ethical dilemma. Should scientists drill deeper beneath Antarctica's ice to uncover more fossils? The continent is protected by international agreements that prioritize preservation over exploitation. Drilling into deep ice layers or into subglacial lakes could yield extraordinary data, but it also risks damaging ecosystems that have remained untouched for millions of years. Some argue that unlocking the secrets of ancient life should take precedence, especially as ice melt continues to expose fossils naturally. Others warn that invasive exploration could irreversibly alter Antarctica's delicate balance, both biologically and politically. The urgency of discovery collides with the responsibility of restraint. The fossil of the Antarctic predator was found near the surface, exposed by natural glacial movement. But what lies further down remains unknown. Should humanity intervene to retrieve knowledge before it's lost forever, or should we wait and let nature reveal its secrets in its own time? The debate touches on the core of what it means to explore ethically. Do we risk destroying the past in our rush to uncover it? This fossil has not only redefined a chapter in evolutionary biology but has also sparked a broader conversation about how we interact with the planet's last frontiers. Antarctica, long viewed as a frozen relic of Earth's past, is now a dynamic arena where science, myth, ethics, and mystery intersect. And as long as the ice continues to melt, that intersection will only grow more intense. Theories and controversies will continue to swirl around the fossil's origin, its significance, and what else may be hidden beneath Antarctica's vast ice sheets. For now, it stands as a reminder that beneath the certainty of science, there will always be questions waiting in the dark. And sometimes, the answers come not with clarity, but with awe. What's next? The future of Antarctic exploration. A new era beneath the ice begins. The discovery of the Antarctic superpredator has set the stage for a new chapter in paleontological exploration. No longer seen as a barren wasteland, Antarctica is now considered one of the most promising and mysterious fossil fields on Earth. Scientists and governments alike are racing to understand what lies beneath its melting surface, triggering a surge of interest in future missions designed to investigate fossil-rich zones that may hold the keys to life's forgotten chapters. Research stations positioned across Antarctica are beginning to shift their priorities. Where climate data and glaciology once dominated the agenda, fossil hunting is now emerging as a parallel frontier. International teams from institutions in the United States, Argentina, New Zealand, and Europe are preparing expeditions to areas where exposed rock meets receding ice. These narrow bands are often where fossils, long buried in sediment, begin to appear. The next decade will likely see a dramatic increase in fieldwork across regions like the Transantarctic Mountains, Seymour Island, and the Antarctic Peninsula, areas already known to harbor prehistoric material but still largely unexplored. One of the most transformative tools in this renewed effort is satellite imaging, paired with high-resolution ice-penetrating radar. These technologies are revolutionizing the way scientists detect anomalies beneath the ice. By sending radar waves deep into glacial layers, researchers can identify geological formations, subglacial rivers, and sediment traps that may have preserved biological remains. These breakthroughs are eliminating much of the guesswork that traditionally plagued Antarctic expeditions. With precise data from space and advanced radar mapping, teams can target their efforts with surgical accuracy, minimizing environmental disruption while maximizing fossil recovery. What excites researchers most is the potential to find even older fossils beneath the deeper ice shelves. The predator discovered near the surface is believed to be around 80 million years old. But some parts of Antarctica, particularly beneath the East Antarctic ice sheet, may conceal sediments that date back over 100 million years or more. In those deeper layers could lie the remains of not just marine reptiles, but early dinosaurs, primitive mammals, and perhaps even species unknown to modern science. These hidden archives are now viewed as the next major frontier in paleontology, a place where the story of evolution may be written in unprecedented detail. As interest grows, the world is witnessing what some experts are calling a new gold rush, not for minerals or oil, but for knowledge buried in ice. Prehistoric paleontology in Antarctica is now one of the most competitive and globally coordinated scientific pursuits. Funding has increased, interdisciplinary teams are being formed, and global cooperation is intensifying. Unlike traditional fossil sites that have been picked over for decades, Antarctica remains largely untouched, its potential virtually limitless. With every melting glacier, it becomes more accessible and more urgent. Yet with this excitement comes a responsibility. Exploration must be balanced with conservation. The Antarctic Treaty System, which governs human activity on the continent, places strict limits on excavation and environmental impact. Future fossil missions will need to adhere to rigorous ethical standards, ensuring that the rush to discover does not compromise the integrity of one of Earth's last true wilderness. Still, the momentum is undeniable. The discovery of one predator has changed everything. It has opened doors to a past we barely understand and inspired a generation of scientists to look southward, toward a continent that once swam with giants. As satellite eyes scan deeper and radar probes further into the ice, we are entering a new era of exploration. And in that frozen silence, a prehistoric world waits, intact and forgotten, for us to find it. There are few moments in science that genuinely shake the foundations of what we believe about our world. The discovery of a prehistoric predator, locked in ice for over 80 million years, is one of them. The shock of uncovering a near-complete fossil of such scale and complexity beneath the frozen crust of Antarctica has reverberated far beyond the paleontological community. It has gripped imaginations across the globe, not only because of what was found, but because of what it means. This wasn't just another ancient skeleton pulled from the earth. It wasn't a fragment, a tooth, or a bone. This was a towering marine predator, an apex killer perfectly preserved in glacial silence, more intact than any similar fossil ever discovered on the continent. It wasn't a dinosaur, and it wasn't a myth. It was real. A superpredator that once ruled the seas of a tropical Antarctica, thriving in an environment so drastically different from the frozen desert we see today that the contrast defies comprehension. In finding this creature, we haven't just added to the fossil record, we've ripped a hole in the assumptions we once held about prehistoric life in the southern hemisphere. This fossil offers more than data. It opens a window into a world long erased by time, a world of warm oceans, towering forests, and evolutionary experiments playing out in isolation. The bones speak of a lost chapter in Earth's biological history, one that developed in the shadows of global science because it was hidden beneath a continent of ice. The implications reach far beyond this single find. It tells us that Antarctica, long dismissed as a frozen void, is in fact one of the richest untapped paleontological landscapes on the planet. It tells us that the oceans of the past were far more complex than we imagined, with predators rising in unexpected places, evolving in ways no one predicted. It tells us that the story of life on Earth is far from finished, and may never be fully written. And yet, as the dust settles and the headlines fade, one question lingers. If one apex predator has been uncovered in the thinning ice of Antarctica, what else lies hidden beneath the miles of glacial silence? What other creatures, ecosystems, or evolutionary anomalies still sleep beneath the surface, waiting for their moment to rise? Because the truth is undeniable. If this fossil was buried here, preserved so perfectly that it defies classification, then this may only be the beginning. Antarctica has spoken, and it has whispered of monsters. But perhaps the real revelation is not what we've found, but what we haven't yet uncovered.